Hello my dear students, welcome back to my channel. My name is प्राची शर्मा और आपको इस चैनल पे देख के बहुत खुशी हुई। आज के सेशन में हम कवर करेंगे पीरियोडिक टेबल का जो फर्स्ट सेट ऑफ इंटेक्स्ट क्वेश्चंस है। हमने लास्ट सेशन में पीरियोडिक टेबल का स्टार्टिंग किया था, दैट वाज द बेसिक अंडरस्टैंडिंग, और आज के सेशन में हम उसके इंटेक्स्ट क्वेश्चंस कवर करेंगे। स्टूडेंट, सिंस आप बिल्कुल स्क्रैच से तैयारी कर रहे हैं मेरे साथ, and today is the second video of this series, so please make sure कि आप जैसे जैसे आगे बढ़ रहे हैं आप सारे questions को solve करता चलें और अपने notes अच्छे से बनाएं। और उसके अलावा अगर आपको कोई भी डाउट है so please make sure to reach out to me at tsclasses@gmail.com। आप मुझे टेलीग्राम पे मैसेज भी कर सकते हैं, आप नीचे कमेंट बॉक्स में कमेंट भी कर सकते हैं, पर स्टूडेंट्स रीच आउट करने वाले तो बनो कि अगर कोई डाउट आ रहा है तो एटलीस्ट रीच आउट तो करो, तभी तो सॉल्व करेंगे। चलो आज का सेशन स्टार्ट करते हैं। Students, so let's get started with today's session. The first thing that we'll begin with today will be the homework question from the last session. So let's start with that. So the question that you had was, why is atomic number considered the fundamental property of an element? So the answer for that is that when we talk about atomic number, it can help you understand how many electrons you will have, of course, and it can also tell you how many shells it will have. It can tell you the number of valence electrons that particular element have. So based on this information, you can easily identify the physical and chemical properties of that element. So therefore it is considered that if we talk about atomic number, that is the fundamental property of that element. Okay, the answer is mentioned on the screen right there. You can take a screenshot of it and write it down, whatever works for you. Let's move on to the questions that we have to discuss today. So the first question is, state the modern periodic law. So the modern periodic law states that the property of elements are the periodic function of their atomic number. That means based upon the atomic number, the properties change and they are repeated over a period of time. Now the next is, name the scientist who stated the law. So the scientist is Henry Moseley. Who did that? Who told us about the law? How many groups and periods does a modern periodic table has? So you have 7 groups and 18 periods in a modern periodic table. When we move on, the next is, what are horizontal rows and vertical columns in the periodic table known as? So horizontal rows are known as periods and vertical columns are known as groups. Then we move on to the next part. It says periodicity is observed due to similar electronic configuration. That means the number of electrons and how they are divided in an element across the shells, how many are present in the valence electrons, all of that helps us understand the periodicity of the elements. Now the next is, how does the electronic configuration change? Number 1, in a period from left to right, and second is in a group from top to bottom. So when we talk about a period from left to right, the number of shells stay constant. Okay, so the number of shells are not increasing. But how does the electronic configuration get impacted? So you have valence electrons getting increased by 1. So as you are moving across a period, the valence electrons are increasing by 1, 1, 1, 1. So you start from sodium. So you have 1, then 2, 3, 4, and you reach up to inert gases which has 80 valence electrons. So this is how it happens across a period. When we talk about a group from top to bottom, in that case, the number of valence electrons will stay the same. That means if it is 1, it will stay 1 throughout the group. But the thing that changes here is the number of shells. So the shells keep increasing by 1 as you go down a group. Let's move on to the next part. The next says, name the elements in each
When we talk about group 1 has one valence electron. That means it can donate one electron and attain stable electronic configuration. When we talk about group 17, they have 7 valence electrons. This means it can accept one electron and attain stable electronic configuration. So this helps us understand whether we are talking about group 1 or we are talking about group 17, both valencies are 1. Okay? For group 1, they are donating one electron. For group 17, they are accepting one electron. So that is why both group 1 and 17 will have the same valency. Okay? Let's move on to the next question. The next question says, correct the statements. The first is, elements in the same period have same valency. So that is not true, because elements in the same group have the same valency. If you talk about a similar group, that group will have same valency. When we talk about the second one, valency depends upon the number of shells in an atom. So that is not true, of course. Valency depends upon the number of valence electrons in an atom, not the number of shells. The third, copper and zinc are representative elements. So copper and zinc are transition elements. Then when we talk about the next one, transition elements are placed at extreme right of the periodic table. So at the extreme right you have inert gases. So inert gases are placed at the extreme right of the periodic table. Now next is definition. So let's look at that. So the first is, what do you understand by periodicity? So the properties that reappear at regular intervals or in which there is a gradual variation at regular intervals are called periodic properties, and this particular phenomena is known as periodicity. Now the next is typical elements. So the typical elements is your third period elements. So that will be your sodium, magnesium, aluminium, silicon, phosphorus, chlorine. They are your typical elements because they represent their particular group completely. So if you study the first elements of this particular group, they are able to help you understand what that particular group is about. So that is the reason why they are known as typical elements. Now the next is orbits. So orbits are the circular path on which your electrons revolve around the nucleus. Now the next question is, name 2 elements that you would expect to show chemical reactions similar to calcium. What is the basis of your choice? So you can pick up beryllium and magnesium. Both of them will show you similar chemical reactions as calcium, because both of them will have the same number of valence electrons and they belong to same group. When we move on to the next one, question number 10. Name the elements, name the metals, metalloids and non-metals in the first 20 elements. So let me take reference from the periodic table. So when I talk about metals, you would have lithium, beryllium, sodium, magnesium, aluminium, potassium, calcium. When we talk about metalloids, that would be boron and silicon. Non-metals would be hydrogen, helium, carbon, nitrogen, oxygen, fluorine, then neon, phosphorus, sulfur, chlorine, argon. So those would be your non-metals. Always take, if you have, so first 20 elements you anyways have to learn and you need to know everything about those elements. But other than that, if you want, you can always take reference from the periodic table because you are still in the process of understanding the chapter. So we do not expect you to have memorized the entire periodic table, but we do expect you to understand what is happening in the periodic table. So always for questions, take reference from the periodic table so that you get familiar with the periodic table more. Let's move to the next question. Fluorine, chlorine and bromine are put in one group on the basis of their similar properties. What are those similar properties? So the properties because of which we have put them together is they are non-metals. They all have 7 electrons in the valence shell, and they have high ionization energy, high electronegativity. So all of these we still have to learn in the next session. So for now you can understand that they are put together because of the periodic table. What is the general name of such elements? So the main characteristic is that they all have stable electronic configurations. They don't combine with anything, and they are the common name for them is noble gases or inert gases. Now the next is question 13. According to atomic structure, what determines which element will be the first and which will be the last in the period? So according to the atomic structure, the number valency. So since it is 6 in the outermost shell, so 2, 8, 6, 7, 8, it will need 2 electrons to attain the stable electronic configuration. So the valency is 2. Moving ahead, is it a metal or a non-metal? It is definitely a non-metal. That is because it is accepting electrons for stable electronic configuration. Next is it a reducing agent or an oxidizing agent? It is an oxidizing agent. The next is, give its formula with hydrogen. So this is an interesting one. I'll do that on the screen for you. So when we talk about sulfur, just 1 second. Yeah. So when we talk about sulfur, I think it should go now. Sulfur, yeah, you can see it. So when we talk about sulfur, it has 6 electrons, 1, 2, 3, 4, 5, 6 in the outermost shell. When we are trying to combine with hydrogen, hydrogen has 1 in the outermost shell. So if it ends up sharing 1 with hydrogen, it still needs 1 more. So that means it will require 2 hydrogens to get connected with it. So this is how your structure would look like, very rough diagram. And what will be the formula? SH2 will be your formula. SH2, because you are using 2 hydrogens. You can also write it as H2S. So H2S, because that is the correct way to write it. Now the next is, name an alkali metal in group 3 and halogen in period 2. So when we talk about alkali metals, so alkali metals are like this. First one, group 3. So in the third group, the answer will be sodium. When we talk about halogen in group 2, so halogen is fluorine, chlorine. So your answer, fluorine, chlorine, bromine, iodine. So that's how you go. So fluorine, chlorine, bromine, iodine. So the answer will be fluorine. Now the next is the noble gas with 3 shells. That means they're talking about third period. So when you talk about the noble gases in that particular chart, if you take reference from the periodic table, in the third period, your answer will be argon. The noble metals present in period 2 and metals in period 3. So non-metals present in period 2. So period 2, you will have carbon, nitrogen, oxygen and fluorine as non-metals. When we talk about period 2, and they're talking about period 3 and they're talking about metals. So if I take reference from the periodic table again, your answer will be sodium, magnesium and aluminium. That is period 3 metals. Next is the element of period 3 with valency 4. So period 3, valency 4. Your answer will be silicon. Then the next would be the element in period 3. So you're talking about the third period, which does not form an oxide. So which one will not form an oxide? Of course, inert gas will not form an oxide. So in period 3, what is the inert gas that you have? That's argon. The next one is the element of lower nuclear charge out of beryllium and magnesium. So the answer will be magnesium, because magnesium has lower nuclear charge. Now the next question is, the electronic configuration of an element T is 2881. What is the group number of T? So since it has 1 valence electrons, the group number will be 1. What is the period number of T? So the number of valence electrons, you can count 1, 2, 3, 4. It will be in the 4th period. How many valence electrons are there in an atom of T? So the valence electrons is 1. What is the valency of T? So it can donate 1 electron and attain the stable electronic configuration. Therefore, the valency will be 1. Is it a metal or a non-metal? So of course, since it is donating 1 electron, it is a metal. Let's move to the last question. Match the atomic number 19, 15, 8, 4 and 2 with each of the following. A metal of valency 1. So when you have a situation like this, always try to write the electronic configuration first. So what will happen in this case is, if I write it, so this will be 2, 8, 8, 1. This will be 2, 8, 5. This will be 2, 6. This will just be 2, 2. And this will just be 2. So let's look at that. So a metal of valency 1. So if you talk about that, so this 2881 will be your valency of 1. So your answer is 19 for Then they're talking about a rare gas. So for a rare gas, that is your helium, that is hydrogen helium, atomic number 2. Helium is a rare gas. The next is a gaseous element with valency 2. So when we talk about 2, 6, so that is your correct answer for that, because we're talking about oxygen. So it's a gaseous element with valency 2. Why valency 2? Because you have 6 in the outermost shell. It needs to be 8. So it has 2 electrons that it can accept to attain electronic configuration that is stable. So 2, 6 is your answer. So your answer is 8 for this one. Now the fifth one is an element of group 2. So group 2 means number of valence shells as 2. So your answer will be 4.
All right students, so this is it for today's session. I hope कि जो हमने आज इन टेक्स्ट क्वेश्चंस डिस्कस करे हैं आपको वो समझ में आए, और अगर कोई भी क्वेश्चन अभी भी आपको प्रॉब्लम कर रहा है, सो एज आई ऑलवेज से प्लीज रीच आउट सो आई कैन हेल्प यू सॉल्व देम. अपने डाउट्स को अपने पास ना रखें, अपनी टीचर्स को ट्रांसफर करें ताकि हम आपको सॉल्यूशंस दे सकें. ठीक है स्टूडेंट्स, सो अब इस सीरीज की थर्ड वीडियो आएगी, दैट वुड बी नेक्स्ट, और उस वीडियो में हम पढ़ेंगे पीरियोडिक प्रॉपर्टीज के बारे में, और पीरियोडिक प्रॉपर्टीज की जो बेसिक अंडरस्टैंडिंग होती है दैट इज न्यूक्लियर चार्ज और एटॉमिक साइज, ये चीजें समझेंगे एंड दे आर एक्सट्रीमली इंपॉर्टेंट, क्योंकि उसके बाद जितनी भी प्रॉपर्टीज हैं वो उन्हीं पे डिपेंड करेंगी. ठीक है, सो we'll catch up in the next session, and please make sure that you like, share and subscribe the channel. Thank you, and we'll see you again.